Hi, we're on page 6 of the chapter 1, section 6 note packet. And again, we're only looking at the examples and we're going to look at a couple of definitions. But if you want to see the constructions, please go to the construction videos, which are on YouTube. So the first example is asking you to construct the bisector of angle XYZ. Everybody's favorite construction. So we're going to set our compass to be any length. Also remember, when you're duplicating angles or bisecting angles, the letters on the sides of the angle don't mean anything to you. The only letter of any importance is the vertex. So I go ahead, I set my compass to this particular length, I put the pointer on the vertex, I reach out and make an arc mark that crosses the first ray, and then I'm just going to reach out and make an arc mark that crosses the second ray. Everything in the middle doesn't really matter, only those intersection points matter. I then take my compass and I'm going to go ahead and leave the radius set to what it is, but again, we're hoping for an intersection point. So when I put the pointer here and I reach out, again, I'm going to leave the radius as it is. I'm going to go to the other intersection point. Pointer goes on the intersection point and I reach out and I make an arc mark. If when you reach out, your two arc marks do not cross each other, then you're going to have to make your radius larger and then recreate the arc marks. So, because again, they do have to cross each other. So what's important to me here is the intersection point and the vertex, and then I just go ahead and draw the angle bisector. The next construction, given the right angle, or right triangle, pardon me, construct a freestanding 45-degree angle. Well, 45 degrees is half of 90. So we're going to go ahead and bisect this angle. So I'm going to leave the compass set to wherever it's at. I'm going to put my pointer on B. I'm going to reach out and make an arc mark. And then I'm going to do the same on ray BA. Now you'll notice this arc mark does not intersect this segment. So I'm just going to line up my straight edge with segment BC. And I'm going to go ahead and extend the segment to create an intersection point. Sometimes you have to do that. So the two intersection points that are important to us are this guy and this intersection point right here. So then I take my compass, I'm leaving it as is, current setting. Pointer goes on this intersection point. I reach out and make a mark. Pointer moves to the other intersection point and reach out and make a mark. I then take my straight edge, line up the intersection point with the vertex, and I draw my ray. This is now a 45-degree angle, and I'm going to just duplicate that 45-degree angle because I want my angle to be freestanding. So I come over here, I draw a line, I put a point on it. My compass is already set to the original arc marks that I previously made. So I'm going to go ahead and just make an arc that crosses both sides of our 45-degree angle. Then I'm going to move over to where I'm building. Pointer goes on the point, and I make an arc that crosses my line and looks large enough for a 45-degree angle. I then come back to the original angle, and I'm going to set my compass to go from intersection point to intersection point. Again, the intersection point we're looking at is where the arc crossed the 45-degree angle. So once that's set, I come back, pointer goes on this intersection point, I reach out, I make an arc mark. I take my straight edge, I line it up with the intersection point and the vertex, and I draw the ray, and I just drew a freestanding 45-degree angle. Okay, continuing on to example C. it asks you to construct the bisectors of the 3 angles of the triangle. Done accurately, all 3 should intersect at a single point. Well, let's see how I do. So I'm going to go ahead and make my radius a little bit smaller. And I'm going to put the pointer on Z and make an arc mark. I'm going to put the pointer on K and make an arc mark. I'm going to put the pointer on R and make an arc mark. I want that arc mark to cross RK, and I want that arc mark to cross RZ. Okay, notice I didn't make the really big arc because it would have been kind of confusing to have them all crossing each other. At this point, I go ahead and I set my compass to anything I'd like it to be. I'm going to make it a little bit bigger, and I'm going to start with angle R. So for angle R's bisector, I want to use this intersection point right here with my little arc mark. I'm going to reach out and make an arc mark. I go to the other intersection point, which is over here on ray RK. I reach out and I make an arc mark. I then use my straight edge and my pen to draw the angle bisector of angle R. Okay, so there's one angle bisector. Now I'm going to do the bisector of angle Z. So I'm going to leave my compass to the setting it's at. I'm going to actually, reach out and make an arc mark. Then I'm going to move to the other intersection point and reach out and make an arc mark. And I think I need to go back and make the first one a little bit bigger. And we can see vaguely that our intersection point is at about right here. So I go ahead, I line up my vertex and that intersection point that I have, and I draw my angle bisector. Now, my third angle bisector should pass through this intersection point right here. So let's see what happens. The 2 arc marks that we're interested in, or the 2 intersection points rather, are this one right here and this one right here, because those are the intersection points that I used or made by drawing the arc with the pointer at vertex K. So I go ahead, I place my pointer on the first intersection point, I reach out and I make an arc mark, move it to the second intersection point and reach out and make an arc mark. So your ray is going to pass through vertex K and that intersection point, which is going to be pretty darn close to where the first 2 crossed. Not perfect, but not bad. Okay, we're going to stop and then we're going to move on to page 7 and talk about the definitions that are on page 7. Hi, we're looking at page 7's chapter 1, section 6 notes, and there's just a couple of definitions on this page that I wanted to point out to you. The first one is for perpendicular lines. It can also be perpendicular rays or segments or planes. 2 objects are perpendicular when they intersect each other and form right angles. So in this particular diagram, line AB is perpendicular to line CD. The symbol for perpendicular is basically an upside down capital T. And as far as the picture goes, since they are forming right angles, you'll notice the right angle marker that's drawn here. Again, it is an arbitrary choice. That right angle marker could have gone in any of these 4 corners since we will have 4 right angles. The second definition on this page is for a perpendicular bisector of a segment. Okay, so perpendicular bisector of segment could be a line, a ray, a segment, or actually even a plane that's perpendicular to a segment at its midpoint. So in this diagram, line CD is the perpendicular bisector of segment AB, and we can see that because F happens to be the midpoint of segment AB, so these two pieces are equal. And then by this mark, we see line CD is also perpendicular. So we would say again, line CD is the perpendicular bisector of segment AB. Okay, we're going to move on to a new video for the last examples in this packet. Thanks.